Oh, all right. It's working. Okay. Sorry for the lack of music. Still getting set up. There we go. Hmm. Okay. Hopefully that muted all that. Huh. Oh no, my login's not working. What? Uh-oh. Oh, okay. Yeah, still getting set up. Okay. Hmm. All right. I think I got everything. I'm pretty sure. Yeah. All right. So, another day, another stream. I mean, another week, but you know. So, today is session 3, and unless we have some guests coming, I'm gonna do some math that's by request from someone else. That's kind of simple. That's kind of easy. Let's see. Everything is showing properly? Yeah. Okay. I'm going to do something different today, and it's just going to be very basic long division. I know. So basic. Simple arithmetic. But again, I got this request until we have someone live join us, so I'll work on this for now. Long division. is where someone has a big number, 1, 2, 3, 4, and they try to divide it by another number, right? Let's say 2. And I know this is like elementary level math, but there's some funkiness that can happen. So here's basic long division in a nutshell, right? How many times does 2 go into 12? Well, 6 times. And when you have 2 times 6, that's 12. Sorry, I kind of jumped. So you look at the first number, right? Because you want to see how many times does this number 2 go into the number 1. That'd be 0 times. Technically, it'd be 0.5 times. But you would just leave it as 0 for now, because that way you want to keep it nice and simple, right? And then you look at the next number, and it becomes double digits, a set, a pair of 12. Wait, not a pair. What am I saying? It becomes 12. This moves to the tens place, so instead of 1 divided by 2, it becomes 12 divided by 2. And then to figure that out, that's kind of where you kind of do it in your head, and you would say, oh yeah, that's 6, right? And then maybe you can kind of go down the line this way. And all this mess right here is just going to be showing your work. And showing your work is kind of important because it explains in detail the process in which you're doing the math, so that way anyone can review it and critique it. Because it isn't always about what you get right, it's just making sure that you're not wrong. So here we have 2 times 6, and now we do 12. That becomes 0, right? How many times does 0 go into 2? None. So then you kind of move on to the next one, which is 3. Carry it down. How many times does 3 go into 2? Well, at least goes into it 1 time, because 3 is bigger than 2. So you at least put 1. Technically, it would be 1.5. But right now, we're just trying to see the most whole numbers they can get into it. So it would be 1. So 3 minus 2 equals 1. And how many times does 1 go into 2? Technically 0.5, but it's not a whole number. So then you move on to the next space, and you carry down the 4. And so this becomes 14. And so how many times does 2 go into 14? And you could do that in your head. That would be 7. So then you got 14 minus 14, and you got 0. And that's where you have the number 1, 2, 3, 4 divided by 2 equals, carry this over, 617. Ta-da! Now that's long division. So that's it in a nutshell, right? But there can be silly things that happen, right? So what if we look at, let's say 1 divided by 2. Nice and easy, right? How do we solve this? Well, how many times does 2 go into 1? Well, it's still 0. And what do we do now? Do we just say it's 0? Do we say 0 remainder 2? Not quite. What you would do is you'd recognize that there's a decimal here. Because every number, like 10, or 4, or 8.5, they all have a decimal place. And technically goes into 0 into infinity. Right? And there's kind of zeros into infinity in the front as well, but no one really thinks about that. Because usually they solve math to round out to the nearest whole number or to the nearest decimal. That makes sense. Stuff like that. They don't usually round up. They round down. So for here, we would add a decimal place, and then we would add one of those infinite zeros until we get, you know, a better number, right? So here we go, 10. Does 2 go into 10? Yeah, actually it does. It goes into it 5 times. So you do minus 10. You got 0.0. I think you just kind of leave out the point, because you carry the point up here, not down there. And then that's how we get, whoops, not 10. 1 divided by 2 equals 0.5. And there we go. Nice and easy. Now we're gonna try to do a little one that's a bit more longer, right? How about let's say let's say 3 divided by, oh, this is gonna not be fun. 9? 3 divided by 9. How many times does 9 go into 3? 0. So now we gotta start adding zeros until this makes sense. Who knows how long it's gonna take? So how about 30? How many times does 9 go into 30? About 3 times, kind of. Do minus 27. Make sure you carry the decimal up, not down. So then you get 3. Then we're just gonna keep adding zeros. Well, how many times does 9 go into 30? Well, it's also kind of 3. But then you do minus 27. And then you have remainder 3. And it keeps going. You can keep adding zeros. You can keep making it 30. You can keep adding minus 27s. And it's just going to go all the way down into infinity. Forever, never, never. And so this is kind of where you get those crazy numbers where when you do it in the calculator, it says 0.333333333, right? Now thankfully it's not going to change. It's not going to be like 3, 4, 3, 3, 3, 3, 3, 3, 5, 3, 3, 3, because if it did, if there's these numbers, not that one. This is the 5. If there's these numbers in the middle, then you'd have to write out the whole thing and include these little weird numbers, right? But then it's going to be 3's all the way. So we could do something nice and simple and just put 0.3 and a line above to show that it repeats into infinity. Just like how you could put 1.0 repeating into infinity, it's all just zeros. You could put 3's here, but no one really needs to know the zeros are there. They're always there. But this 3 is kind of a weird one, so that's why you add it there. So 3 divided by 9 equals 0.3. Repeating, of course. Alright. So, you might be wondering, well, what about... Ooh, do I want to do negatives? What is negative 10 divided by 2, right? It might seem it's a little complex, might seem a little weird, but it's actually very simple. How many times does 2 go into negative 1? 0. And I think you just kind of carry the negative up. I think that's what you do. Yeah, you just kind of carry it up. Pretty sure. Because then you have to do 5, right? 2 times 5. Oh, no, wait. Is that what it is? Kind of. So yes, you carry it up, but the reason why is you have to say, how many times does 2 go into negative 10? And 2 goes into negative 10 negative 5 times. That's why it carries up. It's not just because it floats up randomly. It's because you have to find out what number is 2 times what can cancel out negative 10. So that would be negative 5. And that's how you get minus negative 10. Which then becomes plus 10. And then you get that 0. So you got negative 10 divided by 2 equals negative 5. There you go. And the nice thing about math is that these formulas work for everything, right? So even if we do something a little bit more advanced, which is variables, let's say smiley face equals 3, frowny face equals 2, right? And the way in which you do this math would be the exact same way. So if you had something bizarre like smiley face 8, frowny face 2. No. You could leave another 2 in there. That's fine. And then we have it divided by 4. So then we have, again, smiley face equals 3. So we could just replace that. And frowny face equals 2, right? But what if we didn't know it, right? What if it was just a variable? So let's kind of explore it that way. So then we would do, how many times does 4 go into 3? 0. How about 38? I think that's like 9. What is that, 36? 2, frowny face. How many times does 4 go into 2 frowny face? Well, we don't know what frowny face is, but it definitely goes into 20. So at minimum, I think we can put, okay, and this is where math gets a little funky. Here I could be wrong, but I'm just gonna have fun with it and see what happens. Let's do 5, so minus 20 equals just frowny face 2. How many times does 4 go into 2? We do 0. And then how many times does, we add the decimal. Whoops. How many times does 4 go into frowny face 2, 0? Nope, I messed this up. Yeah, I messed this up. Oh well. So if I just left it as, let's say, frowny face. There we go. Let's cheat a little bit. Let's leave it like this, right? Then that's when you get the remainder frowny face. So 3, 8, frowny face divided by 4 equals 95 remainder frowny face. And you might think, okay, well, that's kind of useless. And you'd be right, because we still didn't figure out what is frowny face. So usually for these variables, they kind of ask you to solve for it. So instead of being 95 remainder frowny face, they would do something like, let's say, whoops. Three, 8, plus frowny face divided by 4 equals, whoopsie daisy, not quite exact, 95. So then, actually, you know what, let's change it. Let's go 96. Okay, so here's a weird one, right? This is a bit far away from long division, because now you're just taking some of the principles of long division, and you're kind of splitting it up into different formulas and different ways to do it, because this is more algebra. And could I do this with long division? I don't think you can do pluses in long division. But let's try anyways. Let's just mess with it. Because sometimes with math, maybe it's understood not just to do it the same way everyone else does it. Maybe sometimes you gotta do things a little wrong, just to really kind of understand it. So let's do 3, 8. Let's do frowny face again. Divide by 4 equals 96, right? So if you look at this, it kind of copies the same thing, right? Minus 36 is 9, so that checks out. And then we have, whoops. Put a 9 there. But the 9 checks out, right? 36. We have remainder 4. And then we have frowny face too. No, wait. What am I doing? I'm getting ahead of myself. 'Cause this would be... should be 5, right? But why is it 6? So if we put something like 6, what's 6 times 4? That's 24. And it should equal 0. Well, then that means that frowny face has to equal 4, right? Because you can only get 6 and get the 0 and make this formula here make sense if this frowny face equals 4. And that's why you get 380 frowny face. I know, a little weird, but that's another way in which you can have fun with long division with symbols. Again, not really the proper way to do it, but I hope it kind of gives an insight where if you work a little bit backwards, and you kind of hit this roadblock where if you hit it from the front side, we're trying to find 380 divided by 4, and then the back side, well, 20 frowny face minus 24, then you figure out that frowny face equals 4, and that's your answer. But again, that's separate from long division. That's more just adding more to that. What are some other weird edge cases with long division? How about... okay, let's try this one. These have all been single digits, right? What if we do a double digit? 12 divided by... no, not divided by. Something divided by 12. That's how it works. Let's do... 144. So how many times does 12 go into 1? 0. How many times does 12 go into 14? Oh, at least once. So that's nice. Then we get 2. Carry down the 4. So then this 2 and 4 become 24. How many times does 12 go into 24? 2 times. Minus 24. Is there anything left to divide? Nope. Just maybe a bunch of zeros. But then if you do a bunch of zeros, then you just get, you know, how many times does 12 go into 0? Well, 0 times. So you either get minus 0, bring down the 0. How many times does 12 go into 0 times, well 0 times, minus 0. So then you could kind of do silliness where you just keep adding zeros and keep doing long division forever. But that's just going to be repetitive, so you don't have to do that. You can just leave it at a nice simple 12. Okay. Now, can you do long division with addition? Let's find out. Because I know that you can have something like, let's say, x plus y divided by z. And written like long division, it'd be like this. So let's give it a shot. And let's try (82) plus 14 divided by 6. Now, normally, you would add these numbers first, right? You would add them first, and then you'd make it shorter and easier to get something like this. 96, right? Sorry about that noise. So then that way, you can get 9 minus 6. Whoops. 9 goes into blah 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 blah. 6 goes into 9 at least one time. So you get 3. Bring down the 6. It becomes 36. How many times does 6 go into 36? 6 times. Nothing else to work on, and it becomes 16, right? That could be a way to do it. But again, if you're working with variables, it kind of gets messy and you have to kind of keep things separate. Because let's say you have, and not just like, you know, a variable like x and y. Let's say you have dollars and, oh, what's the symbol for a euro? Looks like a... Yeah, that's good enough. Alright, and you might think, well, in what world would I need to figure out why would I need to divide 82 and 14 into 6, right? Like, why would I ever have this? This is kind of some dumb math. What are you doing? Well, it's not dumb math. Say, for example, you have a group of friends, and you guys all kind of pull your money together to buy some food, right? But for some reason, you're able to pay in both currencies, and they can take $82 from, you know, your guys' pooled money, and it's $14 for your pooled money, and there's still 6 of you, and you want to say, okay, so everyone can buy this much stuff separately, right? How do you figure that out? Well, another way you could do it is to also separate it, right? You could have 82 divided by 6, so that all becomes $1. Or dollar math. And you have 14 divided by 6. That all becomes the euro math. That's one way to do it. And this would probably make more sense than doing long division. But because I gotta cover long division, I guess we'll just kind of do it this way. It's basically the same thing, just in a different format. Okay. So, let's do... Ooh. How many times does 6 go into 8? At least one time. You got 22. How many times does 6 go into 22? Like 3? 18? So you're left over with 4. And then now you gotta get into change. How many times does 6 go into 40? That'd be 9. Minus 30. No, what am I doing? Not 9. Oh my goodness. It's 6. 36. Alright, and then it just keeps repeating itself, right? So about that much money. So $13 and 66 cents per person. And then you got 14 divided by 6. What times is 6 going to 1? None. About 14. Well, at least 2. So it becomes 12. And then you get 20. And then here's where we get into the decimals again. So how many times does 6 go into 20? Let's say 3. 18. And it just keeps repeating itself. But because money only goes to two decimal places, you kind of have to stop. Oh, right here. So among 6 people with long division, each person will get $13.66 and €2 and €2.33, and one person will just get 1 extra coin from each to kind of handle that rounded number. At least that's how it usually works. I don't know, there's like 2 people that get a coin. It doesn't matter. If you're hanging out with 6 people and you're sharing money and it's getting split between you in 6 ways, I don't think anyone's gonna fight for like a penny. Alright. So that was it for long division. And again, I know it's a bit different from what I was covering before. But this was a request to cover long division. So yeah, pretty good. Alright, now let's try to figure out something else. Is there anything else I could do with long division? I don't think so. I guess if someone had questions, they could kind of join and ask about long division, but there's nothing really at the moment. So now what I could do is post up. Ooh. Tutoring live. Until 8 p.m. PST. Does that look good? Good enough. Good enough. Alright. So, another thing that I could probably cover would be accounting, but I need something to work off of. And thankfully, Bookbuyer got me back and interested in accounting again. But I have really bad habits to break when it comes to like actual accounting and kind of informal accounting. Actual accounting is something you get paid for, it's work. Informal accounting is more like budgeting. And I love talking about budgeting. Budgeting is so fun. So I'll just talk about budgeting. It's like functional math, right? Because I know someone could say, well, when will I ever need to know Oh geez. When will I ever need to know percentages? Right? Say for example, let's go, what is this, like a third? 30% work? 70%? Yeah. Things like pie charts, things like graphs, right? When will I ever need to know this stuff? It's all just math, it's just numbers. Well, when it comes to budgeting, these are kind of visual aids to kind of show how money is spent. So let's say, for example, it's 10, 20, 10. As an example, let's say that you are buying stuff. I don't know what this stuff is. You just know that you won't have money at the end of the month. And you're wondering, man, why can't I seem to have any money? I'm just buying the essentials, aren't I? Well, then that's when you gotta relook at what you're buying. And again, something helpful would be to actually not withdraw cash. I say that because if someone goes to an ATM and they withdraw, let's say $100, right? And then you spend that money on, let's say, groceries, right? Bread, cereal. And gas. Trying to draw a gas canister. I don't know if this is a very good job. It looks more like a watering can. And let's say entertainment. How would I draw a movie projector? Like this? The problem is that if you have cash and you spend on things like groceries or gas or movies or any other entertainment or anything, right? Then unless you keep receipts, it's kind of tricky to figure out, you know, where does that go? What percent is what? Is the food 70%? Is it all going to gas? Is it all going to movies? So in that way, if you're looking at cash, unless you look at receipts and you kind of look over them at the end of a month or at the end of a purchasing period or when you withdraw that, so let's say a week, I don't know. Then you don't know which percent is going to where and what's costing you the most, where you could be saving more, stuff like that. And you don't know which habits to change. So if you're spending a lot of money on, let's say, groceries, well, that's when you get into that old silly avocado toast argument. Oh, that's where all the money's going, right? And, you know, although that's a silly argument, maybe there is something that you could kind of relook. Or maybe instead of getting prepackaged goods, you could get something that you could cook yourself. Or maybe instead of eating out, it could be something that you could make at home. That's supposed to be a spoon. That is not a good looking spoon. Okay. What about gas, right? This is a fun one that I had to do. So I actually looked at how much money I was spending on the gas, which was a lot. And then I figured out, okay, well, if I'm in one place, and let's say, for example, one place, again, unrealistic numbers, right? Let's say one place has gas for $2, and all the other places around my area are all variants of that, right? Again, I'm using very low numbers, just kind of as an example. But then you find one place that has gas that's really cheap. Half the price even. Right? But that place requires a membership. Like some kind of wholesaler location. And you gotta think, wow, I'm spending so much on gas, and I would save so much if I went to here. But this place costs a membership, right? And the membership, let's say it costs, I don't know, $100 a year. Okay? So if I pay this much gas every time per gallon compared to how much I'm spending before, will this cost of the membership offset that? And I once did the math, and for me, it worked out overwhelmingly in favor of getting the membership for the cheap price. Because here, over maybe a period of, let's say, let's use a number, right? 3 months. 3 months of driving, you track how many times you get gas. And then already, you expect here, you spent like $200. And over here, you spent like $100, right? So over that 3-month period where you're getting $1 gas, you only spent like $100. And over here, you spent $200. And then with the $100 membership, that's annual, so once a year, you break even at about 3 months. And then for the rest of the year, for 9 months, that'd be what, 300? You'll spend another 300 on gas, plus the 100 annual membership from before. So let me just erase that. And this would total into maybe $500 a year on gas. Whereas over here, for these 9 months, it balloons baller out of control. Let's see. Yeah, 600. And so without the membership, and just buying gas as you've been buying, you ended up spending $800 for the whole year. And so in that way, if you kind of keep track of your expenses and kind of look for cheaper deals, then you could realize, hey, I saved $300 difference per year, even though I spent $100 for the membership, but because the gas is so cheap, I was able to save money that way. And all of a sudden you spend maybe your spend on gas from 70% to like 40, right? Entertainment's actually a sneaky killer too. Because that one, most of it, I think, is streaming that people like to do. Subscription-based stuff. You know, $15 here. Just do numbers. $15 here, $10 here, $2 here, $8 here, maybe $12 here, $9 here, and so on and so on. How do you analyze entertainment? Well, a way you can do it is you kind of look at how many hours you spend on a day on average with each of them, right? So let's say the $15 thing you use all the time. Let's say that's music, right? How do I draw that symbol? Is it like this? No, that's an ampersand. I forgot how to draw the music symbol. I'm sorry. I'll just do a bass clef. So for music, maybe you listen to it all the time, all day, all night, $15 a month. So it's like 100% of time every day, right? As $10 a day thing, maybe you only use it like for 1 hour a day, right? Maybe it's videos that you watch on your phone. But when you do that, it's like when you're really, really bored and there's absolutely nothing to do. So maybe only use it by 20% of the day. But it's super important. Then you keep looking, right? And then maybe you could find like a justification for each, right? Maybe the things that you don't, use a lot, they're whatever. Maybe use it only like once a week, but it's so important that you don't want to get rid of it. Maybe this thing you never use, so then you can kind of cut it out. You could reevaluate all this stuff, and even then, once you reevaluate on a percentage of how much you use something, so say for example, if this is a subscription that you're subscribed to, but you don't watch it at all, it's just for your friends, but even they don't watch it either, so then maybe we could kind of get rid of that. And so percentages is a good way to kind of reevaluate some of the expenses that you use for entertainment. So, even once you have all that kind of culled out, you need to also reevaluate, well, how important are these things? How important is that 1 hour? Is it really that unsufferable to just kind of sit in, I don't know, like a bus for an hour without having something to watch? Maybe, maybe not. Do you also need music 100% of the time? I don't know. Entertainment is very subjective. And there's a lot of ways in which you can cut down on entertainment, but this, because it's so subjective, people usually try to have like rules of thumb, right? And a good rule of thumb is to maybe limit entertainment expenses to about 20% of your disposable income. And there's also ways in which you can kind of calculate, well, what is disposable income, right? Well, it's not how do I put it? So you have your money. Some of it goes to food, some of it goes to rent, some of it goes to entertainment, some of it goes to bills, some of it goes to debts, some of it goes to commuting, some of it goes to insurance, and on and on and on and on and on, right? Just a lot of line items. So for the line items that you would not count are things like taxes. Or actually, you know what? Well, I don't know. That's a tricky thing though, because some people, they have pre-tax deductions. But assuming no pre-tax deductions, right? You get your paycheck. The tax is already taken out. So rather than just looking at line items, I think that's where they have like a pyramid. How did it go? Oh shoot, I am floundering. There'd be line items where you look at, let's say, yeah, I think it was a pyramid. But they had it very simple. Needs, wants, luxuries. And you'd categorize each of these line items into each of those, right? So let me try to scoot this away so we can kind of get a nice look at it. Whoopsie daisy. So something like, let's say, rent. A lot of people would consider that as a need, right? But that can change. So let's say if someone has a job that they're on the road a lot and they're almost never at home, then that could also just be categorized as a want, depending on the career. So let me kind of do a caveat. Travel job. And I say that because maybe you feel like, oh, I need to have a place to stay, right? I've been traveling for, 9 months out of the year. I need to have a place that is my own, that I have to stay, and I want my own personal space. That's fine. You can classify it as a need if you want. But I would be open to other options, because there's also things like, well, I wouldn't say Airbnbs. Oh shoot, what's it called? There's a thing where if someone has a house that is maybe... No, this is too obscure. Oh well, this is obscure stuff. Maybe a house that's like kind of up for sale, or they're not quite ready to part it, but they also don't want like a renter, and maybe they just want someone to have like a short-term stay, kind of like an Airbnb, but technically not an Airbnb. That could be something, right? If you have a place that maybe you can tolerate staying with a bit, like with a friend or family member, that could be it. For 3 months, I don't know. Maybe that's a bit asking too much. But that is an option. But because a lot of people don't kind of have that, I'm just going to put under needs. That's more the exception than the rule. And then, let's say food. For food, you actually got to subdivide that again. Because a lot of people would just throw food all into needs, right? I need to have food. I need to eat. I have to have this. But then you also got to categorize the foods, right? Let's say some food is... let's just use simple ones, right? Something cheap like cereal. Something like a latte. Something like dining with friends. What poor penmanship. Something like giving yourself a treat at the end of a work week. And something like, wine. Right? Because if you just categorize all this food as like a need, that's not really budgeting. That's just things based off categories. You gotta really subdivide as much as you can. So cereal, it's cheap, and you could say it's a need, but you could also say it's a want if you don't really need to eat. What if you prefer dining with friends and it's somehow cheaper than cereal? Then that would be the need, but maybe that's also a want too. As a latte, maybe you actually need to have caffeine, right? That'd be a need. But maybe it's also a want, because maybe you could make your own coffee, and that would save money. Treat at the end of the week, right? Maybe you think, oh yeah, I had a good job. I deserve this. I deserve something nice. maybe you need that. Maybe you have a really stressful job and you need that. That's fine. But maybe it's also a want, because I don't know, maybe it's the same thing every time, and it's just become part of your diet. But maybe I'm an unhealthy food like ice treat, then it just becomes you're just eating ice cream all the time. And wine, again, maybe you need it. It depends on your life. I don't know what it's like. Or maybe you just want it, because maybe you could actually live without it. But the idea is that you kind of want to just be able to figure out what goes where and really subdivide it, because you can't just have all food go into needs. It's usually kind of a wibbly wobbly mix of both, right? Where maybe you need it sometimes, but you don't need it all the time. Or maybe you want it all the time, but you really don't need it. Who knows? Again, though, that's just budgeting for food. Other things can go into these kind of wibbly wobbly categories, like let's say, I would say socialization is a larger category, right? Because there's a difference between eating for one, and there's a difference between a potluck. Because this ain't bad. This could save you money, a potluck. But also, there might also be other expenses like eating like a weekly dinner with friends. And that might require some reevaluation. Again, not to say that you shouldn't do it. Not to say that it's bad. This can be a really good and important thing, right? Because spending time with friends and family, socializing is actually important for your stress, for your mental health, for your well-being, for having a well-rounded life. Absolutely. Absolutely. But maybe just having agency on where you go, might change things. Maybe instead of having to go out to eat at a restaurant every time, maybe everyone can cook and you guys can have a potluck at a friend's house. Stuff like that. And that might separate, the want from the need. Like, yeah, you need to spend time with friends, for sure. But maybe you just want to go out to a nice restaurant, when maybe all you really need is to just be together and have like a picnic. That can be an option. And stuff like that. Oh, okay. Well, I'm running out of time. So let's see. What did I cover today? Long division, budgeting again. But in a very loose and unstructured way. That's fine. We'll figure it out. But yeah, I think because it's about that time, I will end the stream for now. So thank you for joining. Always appreciate it.